Hello, welcome back. So in this part, we are going to discuss the steps that we are going to follow for designing lacing system. So till now, we have seen the general requirements of the lacing system. Then we have seen the designs considerations that we have to consider while designing the lacing system. Now in this part, I will be discussing the steps, various steps that we are going to follow to design the lacing system in the built-up column. So first step is to choose the lacing system. So either we use single lacing system or the double lacing system that we have to choose as a beforehand. And after choosing the single or double lacing system, we also choose the angle of inclination with the axis of the compression member. So angle of inclination, which is the theta value. So theta value is also need to be chosen beforehand. Now in the second step, we are going to find out some values. So for a given shape, we generally find out the gauge distance, which is the g value on each side, and then we try to find out the distance a between the bolt center. Then we compute the spacing. So I will show you that in the diagram. Here you can see this is the g value, and g value is basically the distance between the bolt. So for example, if I'm providing bolt here, so center of the bolt hole to the edge of this member, so this value is the gauge length. So gauge length, I hope you remember, gauge length should not be, it should not be less than 1.5 times of bolt hole. So this is how we find out the g value. So once we find out the g value, we try to find out this a value. Now a value will be the sum of s plus 2 times of g from both ends. So a value is required to be find out, and we can easily find out this s value. I have already explained when I was solving example 1 of this lecture. So in that we have find out the spacing. You can see here, this is actually that spacing which is required to be find out, so that ryy and rzz is equals to, is equal to each other. So this is that s value, and g value we assume what will be the gauge value, and on both sides, so we find out a in step 2. And also we have chosen the theta value. Then we also find out the L value. So L value can be easily find out, because if by chance, one second. So L value can be find out from this formula. How? You can see here, if I make this triangle, and this value is L, this value is L, for example, and this one is theta, this one will also be theta. So you can see this one, this becomes the isosceles triangle. So if I want to find this value, we already know, which is a, this one. So how do we find out this L value? So if I bisect this value, so it will be L by 2, and this one will also be L by 2. So simply L will be equals to 2 times of a tan theta. I have simply done the trigonometry here, so you can try that. So for single lacing, it will be 2a by tan phi, and for the double lacing, it will be a by tan phi. Because in the double lacing, it will be less value. If it will be the half of that value. Okay, so this is how we are going to follow the step 2. In the one more thing, the length of the spacing can also be calculated. Like I have just made this triangle. So this triangle, the length of this this is L. So we can find out this L value also using the trigonometry. And using the trigonometry, we can say L is equals to a by sine theta. Now in the step 3, we will find out the slenderness ratio of the, we will find out slenderness ratio of the lacing bar, and then we will check the slenderness ratio limit, which should not exceed 145. So first, uh, in the second step, what we have done is we have calculated L value. Now we have to check whether this L is sufficient or not. So for that, we have these two value. So we have now L value. We will find out R minimum from the steel table, and lambda max. We can easily find out uh, from the conditions which will be given in the question. So it will be clear when we will solve question. Okay, so then this ratio is basically used to check whether L value is sufficient that we have calculated in the previous step or not. So in this we are actually checking the slenderness ratio. Then in step 4, we will find out the length of each lacing between the inner and bolt, and then we will find out the LE value. So this LE value will be the effective length of the lacing bar. This one. So this one is L, and this LE will be the effective length for this, because now we are going to find out slenderness ratio of lacing bar. Initially this was to check the this spacing L. So for single lacing we know that LE will be equals to L, and for double lacing it will be 0.7 L. I have already discussed this earlier when design specification would be, when I was discussing design specification. For welded connection also, LE will be 0.7 times of L. Now going to the next step. In the next step, we are going to select the size of the lacing bar, and in the size, we are going to find out the T value with these relation, these recommendation of the IS code. Similarly, we will find out B value, and then we are going to find out the slenderness ratio of the lacing bar, and we will check whether it is less than 145 or not. So for flat bars, lambda lacing will be LE. I have already derived this formula. How this formula is arrived at, you can check in the previous part. Then in the second, in the next step, we are going to find out compressive strength of the lacing bar. Now, as you can see, we are going to connect these lacing bars, so they will be having their compressive strength also. So in the step 7, we will calculate that. And spacing, compressive strength can be calculated by using the FCD value. So FCD value for the lacing bar can also be calculated, because the lacing bar will also be having this lambda. So based on this lambda value, we can calculate FCD value for the lacing bar also. Then in the step 8, we will find out the transfer shear, and this transfer shear we will find out just to find out the actual force the lacing will experience. So this will be the actual force the lacing will experience, and if we have calculated the strength of lacing bar in step 7, then we will compare that. If the strength of lacing bar is more than F value, then we can say that lacing bar will be safe, or if it is less than, then we have to revise the design of lacing bar. Then in step 9, we will compute the compressive strength, compressive stresses and tensile stresses in the lacing bar, which should not be less than, which should be less than the permissible compressive strength and tensile stress. We will, we will see how do we find out compressive and tensile stresses in lacing bar and in various members. We will check that in the question when we will be solving the problem. And in step 10, we are going to design the connection. So we will select the bolt diameter, and then we will find out minimum width of flat bar, which is the, which is basically, by selecting the diameter of the bolt, we can easily find out the minimum width, because as per IS code, it is, B should not be less than the 3 times of D. Now D is the dia of the bolt. This is what condition I have explained earlier as per IS code. And after calculating the value of B, we will find out the number of bolt which will be required for connecting the lacing system. So number of bolt can be calculated by using this relation. So N will be equals to F by R. Now F is the force in lacing bar and R is the bolt value. So it will be the bolt value and F will be the force in lacing bar. So from this relation we can find out number of bolts required to connect the lacing. Then in step 11 we will design the end connection for the lacing system and we will check if the number of bolts are sufficient to withstand the load in the member. So these are the process that we will follow to design the lacing bars. So in the next part we are going to solve the same example that we have solved earlier, example 1, and this time we are going to design the lacing system for the same example. Thank you.